All right, so we're doing our lecture today on password attacks. Let me go ahead and share my screen. This should be a review from today, but I'll go through a couple of demos that Corey didn't do. So again, this should all be a review from the lectures that you saw or the pre-work over the weekend. So we're going to talk about passwords. We're going to talk about how we can attack them, what makes passwords strong, how we can securely keep passwords. And we're going to start with this comic, of course, because there's always a relevant XKCD. And the point this comic is trying to make here is that people have become very good at making passwords that are very easy to guess, but very hard for us to remember. And this is a bit of a problem. It also is talks a little bit about how we build our passwords and we force you to use certain characters or certain lengths of passwords. But again, we end up defeating these ways by being able to guess what the passwords are. So let's take a look at what we're talking about today. We're going to talk about how we actually attack passwords. What's our strategy of defeating password authentication? We're going to talk about hashing, and kind of take a little review on that because that's relevant in how we store passwords, which is relevant in how we'll attack them. Talk about different types of hashes. We'll talk about the different scenarios you'll be in where you'll decide to do some kind of password attack. We'll talk about the methods and some specific tools. So let's go through. Again, password attacking. We're attacking the authentication mechanism of some kind of service. So the first thing I'm going to ask is what is authentication? Go ahead and unmute yourself. Give us a quick response of what is authentication.
Like a validation against something that's stored within somewhere?
Try something else.
Proving you are who you say you are.
There you go. It's that whole process, proving you are who you say you are. And one method of doing that is using passwords. That's the most common way. We're all familiar with it, right? You want to prove who you are. You have some kind of ID, user ID, and you have some kind of password. And if you know the password, that must be, that's how you prove you are who you say you are. So usually, right, we have user ID and password, most common way that we can do this. And so what is the weakness of this? Or what can happen if we have insecure passwords, right? Well, what if you don't change default passwords on devices? What if you use passwords that are very easy to guess? You have passwords that are hard-coded that are not being changed, or you're reusing passwords. And we've already seen reusing passwords when we took a look at one of the machines last week, right? So this is real, it happens. Reusing of passwords is a weakness. It's a vulnerability. It's one way we can attack passwords. So how are we going to attack them? Well, our main focus on this is getting hashes, password hashes, and breaking those password hashes. And if you recall, I had told you that hashing is a one-way trip. Well, we're going to show you how we can kind of, I don't want to say get around that. It's still going to be one way, but we're going to use some kind of logic here and figure out what a hash was originally. So default hard-coded passwords are common on all kinds of factory devices. If you have any kind of like Internet of Things devices, you probably had some kind of default password. Talking about toasters, refrigerators, anything like that. Okay. So again, you've probably done this before, and if you haven't, I encourage you to. You can look up default passwords when you are trying to log into some kind of device, right? You find out what the device is, you find out what the version is, just go ahead and Google default credentials for this device, right? You can get passwords from computer memory using specific techniques. You can guess easy passwords, right? If people just don't decide to use a strong password. And we could use combinations of brute force or dictionary attacks, right? We have some kind of list of passwords. We're going to try all of them and see which one works. The other common security risks is users and admins using the same password for different accounts. Again, password reuse is common, and it is not a good thing, right? So I want to talk a little bit about biometrics first. There was a time not really that long ago where people thought that biometrics we're going to be like the number like that. That's like the best way that you can do authentication. I want you guys to take like take 20, 30 seconds and think of some reasons why this is not perhaps the best way to do authentication. What are some downsides of biometric authentication systems? Take some time, think about it, and then respond.
I mean, the obvious downside in my mind is just that computers are not experts at recognizing human biometrics yet. Like, we can't easily replicate that on a computer level.
Yeah, so I guess where you're going there is like some kind of like false positives, because there's no way we can. Yeah. So if we got false positives, also false negatives too, right? I guess I can imagine a situation where the whatever you're using as identification can change over time. That could be like, what if you're using fingerprints as identification and someone loses their hand? Now, you can't use that. What else?
You leave your fingerprints on everything.
So like, I guess other people getting access to your biometrics.
Yeah.
True. Absolutely. You leave them everywhere. What else?
With stuff like facial recognition, sometimes like a picture of a person will work just as well as their actual face.
Oh, and I'll follow that under, I guess, false positives and also different kinds of attacks for this. So yeah. I'll say sometimes sharing passwords is a solution really quick, right? Sometimes sharing an account is a solution, temporary solution. You cannot do that with biometrics. Not really, at least. Can't really share somebody's eyeballs or things. What else? What else makes biometrics not as good as passwords? Let me see if I open up chat too. Tim says, please don't need a warrant to unlock personal devices that are biometrically locked. I'm not a lawyer, I'm not sure.
I guess it's also just like the manner in which, however that's going to be stored, it's a lot of personal information that's just out there. So harm reduction becomes more difficult, I guess.
Yeah, for sure. There's definitely, you can't have an anonymous account now really without giving out that personal information. I guess the last thing I'll add here is you have a limited number of biometric things you could really use, right? You have your 8 fingers and 2 thumbs and your 2 eyes, and I guess you have a DNA profile, but maybe that changes over time. I'm not sure, but there's a limited number of things you could use for biometrics. So, biometrics is definitely useful for authentication, but it should not be the only thing. You use it as a multi-factor. Cool. So just a little talk about biometrics. So how do we get word lists if we're going to do some kind of dictionary attack? Some have already been created for us. Like we got the famous RockU word list of, well-known or common passwords that have been, scraped off the internet. But we could use tools to generate our own word lists. These tools I'm referring to are Crunch and Cool. Cool is a tool for generating word lists. Crunch is a tool for, modifying word lists certain ways. For example, you could use Crunch to, scan a website for, words of a particular length, get the whole list of those words, and then use Cool to do, things like add, 1 or 2 digits at the end of the number, or, do some kind of simple replacement of O's to zeros or something like that. But the world is your oyster. You gotta be creative and think about what do people's passwords look like, and what might common passwords be. This kind of brute force / dictionary attack, the only way it wins is if the password is on that list that you get. If the password's not on the list, no dice. So the better the more you know about your target, the better a better chance you have of generating a word list that will have the password on it. So besides this being a little blurry, we have I referenced two different things here, brute force and dictionary attack. They're really similar. What I'll say is brute force's attacks are a little dumber, and they're completely, going to try every single combination. Whereas a dictionary attack, you're going to use a list of words, usually with some kind of theme or something like that. They're smarter. They're going to be shorter, right? The bigger your dictionary is, right? The wider your net, the longer this attack is going to actually take. But the higher your chance the password's on there. So you're always going to be kind of making these trade-offs between using a really big word list or using a common word list, and hoping it's in there. Ways that you might be defeated when attacking an online password. When you're guessing passwords, there are, and you guys have probably already been familiar with this, rate limiting mechanisms or account lockout policies. You try to use to log into an account several times. This has probably happened to everybody where they forgot their password to something. And eventually, you can only try and log in 3 seconds from now, or 5 seconds, or 10 seconds, or, a minute, 2 minutes, and it scales up usually. Right. So this is one way that you can, that people on the defending side can defeat these types of attacks. And let's see, one way that the red team, that the bad guys can kind of defeat this mechanism of stopping them is using a technique called password spraying, where instead of trying to brute force one account with a whole list of passwords, they're going to try a large number of accounts and try and find which ones have insecure passwords. So, maybe they'll try a whole bunch of different accounts with a whole bunch of very common passwords. And, sure, they can only try 3 or 5 times, but they're going to try so many different accounts that hopefully, the math works out for them that one of those accounts has a weak password.
So it's a shotgun.
Yes, it is a shotgun. It's like, we've got a list of accounts. Let's try. Hopefully one of them works. Absolutely. Thankfully, people are very bad at making passwords. Well, I guess that's not thankfully for us on the blue side, but people are predictable. They'll usually make passwords that are easy for them to remember, unless you force them not to. And yeah, that's password spraying. So let's talk a bit about hashing again, and how people should be storing passwords on their servers. So again, you have plain text. You run it through a hash function, you get hash text out. I'm not going to worry too much about how the hashing algorithm does its math, but just know that we're taking the password, running it through a function. You get some hash out. That doesn't mean anything. You can't take that hash and go backwards, not with math at least. So how are we going to defeat this? Again, hash algorithms are one way. I cannot use math to take a hash and go backwards. It's not the way we're going to defeat this. So databases and other password storage mediums should be hashing their passwords. That way, if someone does break into their database, all that's there are hashes and not the user's passwords. And again, you have a whole list of hashes. Mathematically, you shouldn't be able to take those hashes and go backwards, right? That's the whole point of the hashing algorithm. Now, good hashing functions should avoid collisions. This is where 2 different inputs hash to the same output. Bad hashing algorithms have more collisions. So bad hashing algorithms are the older ones, like MD5 is known to have more collisions. The more popular ones, the newer ones like SHA-256 and 512, much less frequency of collisions. Good hash functions have high entropy, which means small change on the inside means big changes on the output side, right? Change one character on a file, the hash will look completely different. No similarities. And the way they should store passwords in a database involves this process or this practice called salting, where you will add or append a string of characters to the front or the end or some part of the password before you hash it. We'll talk a little bit more about what salting looks like. So let's talk about the different password hash classes, the popular ones. There's SHA. There's NTLM and LM, which are 2 Windows type of hashes. There's MD, like the MD5 hashes. And we have a tool here that Corey, I think, demoed, this hash analyzer. So say you find a hash, you don't know what kind of hash it is. You throw it into hash analyzer and determine what the hash is. It usually determines it either by the length of the hash, because every hash type has its own length. And, that's one way at least that they can determine what type of hash. There's also a couple of tools on your Kali machine already for determining hash. I think it's called Hash ID. You write from the command line, but pretty cool tools just to determine what type of hash you have. Okay, so what are the scenarios where you're going to be attacking passwords? Well, there's two main ones. There's the offline, which we're going to call local password attacks. This is where you have the hash. It's on your local machine already. You're going to try and break it. So, you've got the password hashes already. You want to crack them. The alternative is online, and this is remote. This is where you don't have the hash. You have some kind of like login form, and you're going to try and brute force that login form or use some kind of dictionary attack against that login form. And hopefully, you don't get account locked out. Hopefully the password's on there. All right, so the example here is login form. And when you're doing it, you're going to need to consider the defenses. Online password attacks are going to be noisy, for one. You're going to generate a lot of traffic trying to do it. Then also, there's going to be people on the blue side defending that are going to be looking out for this and say, you tried to log in, 3 times in the past 0.3 seconds. We're going to throttle you a bit. You're not going to be able to do it. Okay. But meanwhile, if you're offline, if you already have the hash, right, you can take as much time as you want to break that hash. It really just kind of depends on the computing power that you have set up for you. So we have brute force. This is just guessing, try a password, compare it to the hash, right? Just like take some random string. If you know what type of hash type, what algorithm was used to generate the hash, just try hashing it and compare. Right? This can be used against salted passwords, doesn't really matter. And it works locally or remote. You're just going to try, I'm always reminded of that Family Guy episode where Stewie forgets the number for his parents and he tries like 111, 11111, and then just goes up every single time, right? This is brute force guessing in here, right? Small, right? There's what am I saying here? Small computed at runtime. So the idea here then is this takes a bit of time because you're going to hash everything inside this dictionary. So sometimes these hashing algorithms take a little bit of time to run. Right, the actual compute time depends on when we start. It can take a very long time to brute force, right? One way that we can go about breaking password hashes or one idea is having a rainbow table. And these are really big tables, really big files. I'm talking like on the order of gigabytes plus, and they are pre-computed hashes linking passwords to a hash. So, imagine you take all of the common passwords and all of the different common hashing algorithms, and you just hash them all already. And now you have a big table. And you can just look up. So like say you found a hash. All right, let's look it up. Is it already on this table? We already did the work of hashing everything. And this is a rainbow table, right? You might see these used on like actual red team engagements. If you like Google online, you'll find like sometimes these big, like even on Rolly briefcases, big hard drives. So actually physically big, like potentially extremely large. Again, this will be very quick sort of attack because you already, you have the hash you're trying to look up. You have a giant table. All you need to do is look it up. And if it's on that table, you're already won. So very quick if it's on that list, but if it's not on the list, it's not there. And you can't use this against salted passwords. This tool or the notable tool that's available on Kali is called a Rainbow Crack. We're not going to be using it again because it requires a whole lot of actual resources. But you could take a look at what rainbow tables look like online if you like. For Windows hashes, there's pretty much 2 main things that you need to know. There's 2 versions I told you. There's LM and NTLM. LM is the older version and is a very weak hashing function. Like it converts all the characters to uppercase and then splits the password into a string of 7 characters and then hashes each one of those. So imagine, a password that can only be 7 characters long and they're all going to be uppercase. So, no matter how big you make the password, it's just going to be chunks of no more than 7 characters long. And as you can imagine, this is not very hard to crack. So anytime you see a Windows LM hash, you'll be able to know this is always crackable. Always, 100%. LM hash is always crackable. So Windows got smart and they were like, hey, we should probably fix this. And so, with Vista and up, they have NTLM. On modern Windows, they disable LM by default and use NTLM. It is an improvement, but again, it doesn't use salted hashes. It's vulnerable to rainbow tables, vulnerable to brute force attacks. So what's the takeaway from this? If you see an LM Windows hash, you can crack it 100%. If you find one like in your adventures through PWK and you see an LM hash, 100% you can crack it. You should just got to find out how. Now you find an NTLM hash, it's more dicey. Not 100% sure that you'll be able to crack it. Cool. That's a big takeaway for Windows. So let's talk about the tools now. And I'm going to demo a couple of these tools with you. So for generating word lists or for using word lists, PWK, I encourage you to use rocku.txt. It's huge. It's a huge word list. There's smaller ones, but rocku.txt, if it's not for PWK, if you're doing a password attack and it's not on Rocku, it's not meant for you to be able to crack it, is the idea. For generating word lists, you have Cool and Crunch. I'll demo Cool. You could use Crunch on your own time. I don't think you're going to need to actually create any word lists, but you can try. It's worth taking a look at. We'll do it. And then we'll take a look at some crackers. We'll take a look at John the Ripper and not Hashcat because that's not installed. And we'll take a look at Hydra. Cool. Oh, and yeah, let me show you crackstation.net. So crackstation's cool. So here's crackstation.net. This is an online rainbow table. What's pretty fantastic about this is you can just paste a hash right in there, confirm that you're not a robot and type crack hashes. And the way this works is it has a giant rainbow table on the back end. It looks for that hash that you provided it and says, has it already been hashed before? And if it does, it'll just give you what it was. So let's generate a hash. Echo. That's how you spell volleyball, right? Into MD5. Okay, so all I did here was take the string volleyball and get the MD5 sum of it. Copy. I'll throw this into Crackstation just to confirm that this works. Right, just paste the hash, prove I'm not a robot, always scary. All right, I did it. Right, and then it looked it up in the table. I found an exact match with the MD5 hash of volleyball. Quick questions on rainbow tables in general. Not so much this tool, Crackstation, right? I think it's easy to use, but understanding how we were able to take this hash and go back to volleyball.
I thought hashes were only one way.
Yes. Yes, they are. So we're not using math, right? We're not using math to take this and go backwards. We're saying, what if we already took a bunch of common words, hashed them, and saved them in a table? So that way, if you look up the hash, you can find what it originally was. So we're being kind of clever here. We're not using math to go backwards. Hashes, right? We can't do the math to do that. But we could just keep a record of this is what it was originally. This is what it hashes to. And because hashes always will hash the same thing every single time, right? We just keep it up, look it up in a big old database. And then that's how we get the result. Does that make sense?
Yeah.
Cool. Very important.
Hey,
yeah.
Matt, sorry. Is it common to like a company uses their own MD5 algorithm so that let's say Polyball
If they're
wouldn't
if
need all
they're
this?
rolling their own crypto, they should not be, right? These algorithms, right? These hashing algorithms and encryption algorithms are well known. And I would strongly suggest that if you were a company that valued your security, you would use well-known, established algorithms that have a history behind them. If you make up your own, yeah, I just don't trust it. So are there companies that roll their own crypto stuff? Yes. Is that a good security habit? No, I don't think so. But yeah, you could make your own hash algorithm, right? Like I think in the web dev program, we show the students a way of like making really crappy ones that have lots of collisions. But you don't want to do that. You're going to want to use ones that like, you know, the eggheads over at MIT and DARPA put together. Cool. Does that answer your question?
Yes, thank you.
Cool. All right. Rainbow tables, check. What's the next thing we want to demo? I think it was, okay, let's demo cool. Just so you could see what generating a word list would be like. Here we are. So let's say I want to attack offensive security. And let me make sure I don't have this set to use a proxy. No proxy right now. No proxy right now. All right. So let's say I want to attack offensive security. Maybe they have some, new person there. I have an account I want to attack. I want to make a password list. And I think, if they really love offensive security, maybe they're going to make a password that has something from this page on it. One of the words from this page. I don't know. That's the idea. That's the story and we're sticking to it. Okay. So how would you do it? You'd use a tool called Cool. Cool. Let's try -- help first. Right. So Cool. You give it your options and you give it a URL. Important options here are, and again, because I'm just demoing this to you, showing you the depth. So how deep do you want to spider into the page? How many links are you going to follow? Right. So essentially what this is going to do is look onto this page or the page that I give it and look for words in the text. Do I want to spider off of other sites? Do I have a minimum word length? Maybe useful if I know passwords are of a certain length. User agent if I need to send a user agent. All kinds of stuff here. So let's just go ahead and try it out. Cool. -D 1. So that way we're only going to go down one level of depth. -D 1. What else do I want to add on here? Let's get a word length of 8. So I'm going to say their passwords are at least 8 characters long, maybe. And we will let's give it how do I write it out to a file? Right. So let's write it to a file. /root/grep. We'll write it into there. Cool. offsec.txt. Right, that looks good. Depth of 1, words of length of 8. Here's the file I want to write it to. And then we just got to give it the URL. So let's grab this URL here. Paste. Let's try it out. Cool. And so what this tool is doing is going down, made a request to this website, looking through the text of this website, looking for anything that is of, oh, look, it finished, of length of 8 or more, a word of 8 or more, and write it to this file. And the idea here is I can now use this file. Let's see how big this is. Right, I can use this file, and maybe I can, make some changes to certain things. I want to say, oh, maybe O's should be zeros, and maybe add like two random numbers at the end of it. You get your idea. You could make your pasta however you want. But the idea is now I have a word list, or at least an entry point for a word list. Any questions?
Yes. When you said depth of 1 and it was like the maximum is 2, what did you mean by depth?
Just like how deep am I going? That's like 1 level deep. If I follow that, or yeah. How deep on the website am I going, right? This is the root of the website. If you click here, now I'm on /courses and certifications. If I'm on something else, it's one deeper. Think back to when we were doing on essentials and you had to spider that website and you had to go down as deep as you could with wget. You did wget recursive. That one is down as far as it could. Here I'm talking only a depth of 1.
The only reason I ask is because it only gave you a max level of 2, so it wouldn't continue after 2, correct?
I mean, if it gives you only a max level of 2, then I would assume that 2 is as deep as we can go. You can try it. We could try it. You want to try it? Here, I'm going to show you guys how to answer your questions when they're like, hey, will it work if I do this? The answer is, I don't know.
No, but what I'm saying is like if you wanted 3 or 4 or 5 or 6 or anything like that, you'd be missing out on those pages then.
Oh, let's see.
I read it as a default value of 2. I don't know if I read it wrong.
Yeah, that says default 2.
Gotcha. Sorry about that.
There you go. You get a question like, will this flag work? Just try it. I don't know. Hey, stop. Thank you. All right. Next tool we want to talk about. Crunch is one you would use. You'd like take this word list from Cool and pipe it to Crunch. And Crunch has a bunch of options to modify your word list. Like I said, add numbers to the beginning or end and stuff like that. I'm not going to demo this one, but you can take a look at it. Let's talk about the actual like offensive ones now, the crackers. So I'll demo John first, and then I'll demo Hydra. Hashcat, you'd have to install yourself. If I recommend, if you do want to play with it, to use it on a machine that has a powerful GPU, because I think that's the advantage Hashcat has over John, is that it uses your GPU hardware for the hashing, whereas John uses your CPU. Unless you plan on building a crack station, like a machine specifically for cracking, doesn't matter. We're going to use John. Okay. So here we are. Clear, now clear. We want to unhash. Let's say John -- help. So in order to use John, you have John, your options, and your password files, right? So I'm going to show you where my password files are, right? We have cat etc password. I don't want to do head etc password. Okay. So here is the password file, right? We should kind of remember, right? It has the user on the first entry, separated by colons. We have other bits of information. Can anyone recall what does it mean if the second field is just an X on this password?
It has a password.
It has a password. And where are those passwords stored?
Etsy shadow.
Yep. So head, Etsy, shadow. Yep. Pooch got it. Yes. Good. All right. So here is where that actual password is stored. I'm trying to get it. I'm just looking to see where the colon ends. I think this is all of it. And you could do a little Googling as to the actual syntax. You'll usually see like $sign and a number in the beginning, $sign number, $sign. This is one way you could tell what kind of hash this is. You just kind of look it up. Hash start $6. I'm pretty sure that's something. But they all start a certain way. This is not the best site for it. Yeah, MD5 starts with $1, SHA-512 starts with $6. Right, so that's one thing to know about these things. I believe this part is the salt, and then there's a bunch else here. We're going to use John to take a look at this and to solve it for us, to break this hash. So the first thing we need is the file in the format that John accepts. And John accepts it like this, but with the actual hash inside here instead of this X. So John has a helpful utility called unshadow. Let's actually go to the John the Ripper. Oh, this is probably gonna, yeah, cool. It knows what I'm talking about. So this is the official documentation for John the Ripper. Recommend you keep it open whenever you are using it, because John's a little finicky. I won't lie, I always have it open. And I do John the Ripper examples. So they have a really good example page. Yes, so I usually have the /John open of their documents, and I usually have their usage page open. And so if you take a look here, the first thing you need to do, you need a copy of your password file. If your system uses shadow passwords, you may use John's unshadow utility to obtain the traditional Unix password file as root. So it's saying use unshadow with your, give it a password file, give it a shadow file, and then write it to a new file. So let's take a look at that. If I didn't know how to use unshadow, I'd do unshadow -- help or -h, then it gives you the usage there. Here, show you. Okay, so we'll do unshadow /Etsy password /Etsy shadow, and I'm going to write it into a file called unshadowed. I'm going to I'm going to head unshadowed because it's kind of big. Right now, the only difference here is it just grabbed that thing that was in the shadow file and kind of put it in here. And now I don't have to worry about, manually making the file look like that. Cool. Cool. So now we got the thing unshadowed. What do we got to do next? Well, it looks like you can give it, I want the examples here. You can give it a word list with this word list equals option. So let's try it. John, and we'll do it unshadowed -- word list equals, and the word list I'm going to use is RockU. User share txt. And now typically you'd need to give John a few more options, and it depends on what type of hash you have. Sometimes John is able to easily identify the hash. Sometimes it's not, and you have to specify what type of hash it is. I believe in this case, it should be able to easily identify. I want to add, I think -very verbose. Will this do it? No, never mind. We won't get to see it happen at the same time. Okay, loaded 3 password hashes with 3 different salts. I think it got it. Do John unshadowed -- show. And it was able to, let me make it bigger. It was able to crack those passwords. So when I give John the unshadowed file now and tell it to show me, you can see here I had the user root with the password Tor. I had the user Bruce with the password Batman. I had the password user Peter, the password Spider-Man. That one went really fast. Generally, depending on the type of hash and the word list and how long you're going to try, it could take a long time. It could take a long time, on the order of minutes to hours plus. I specified these. These are names that are kind of at the top of RockU so that it would go by very quickly. Cool. Questions on using John to attack a password locally? It looks easy when I do it, but I promise you, when you try it yourself, you're going to fight with John. It's not my favorite tool.
Just a quick technical question.
Sure.
When you do that, John rewrites the file is basically what it does.
No. So I'll still have that unshadowed file, and it'll still look like that, right? It still has the hashes inside it. But if John makes its own like little database. So if you give it the file again and give it the option dash dash show, it'll show you what it cracked.
So maybe you would cat that or put that into another file.
Yeah, I'd put that into another file, right? Like if I've cracked some passwords, I might have a file that I save myself with usernames and passwords separated, because again, once I have them cracked, right, maybe they're reused somewhere else, and I'll save them. That's kind of what you want to be thinking when you're in PWK. You find any password and user accounts, save them, save that stuff and try it again. Try it somewhere else. But yeah, I would save this. I'd save this with a little note. Absolutely. Okay. Let's take this home now. Let's do an online password attack. So for this demo, I'm gonna need a little bit of help. The first thing I want to show you is I have two machines. I'm not going to do this on a PWK machine. I'm going to do this on my own machine. I have my root at Kali here, and I'm also running this one right here, Metasploitable 2. They're both on the same network. We're not going to need to look at this Metasploitable 2 anymore. Oops, that beeped at me. What I want to do is attack that Metasploitable 2 machine. It has a web server on it. I know this, I'm telling it to you now. So the first thing I want to do is how do I find out the IP address of this machine I want to attack?
Host or one of those.
Well, let's see. Host will do what? Oh, it's the same menu. How can I find out what the IP address of this machine is when I'm on this machine?
Well, you said it's on the same network, so you could use Nmap to scan your network.
Hell yeah. All right. This is where I want you thinking. Okay, I use Nmap to scan my network. What am I going to put in here?
PN for ping scan.
It's PN like that, right? Is it? Let's double check. Nmap ping sweep.
I think it's capital P, lowercase n.
Is it capital P, lowercase n? I see dash SN. What is it? Someone help me. I see dash SN. What is that? I see dash PN, no ping. What do we want to do? You can Lul at the same time. What do I do? How do I discover the host? Help, help. I can't find my target. What do I do?
I think it's SL.
SL, what is SL?
Simple list target to scan, I think.
List scan?
Isn't it SN for
Ping scan.
Okay, host discovery. SN, no port scan. This is what I want. So this SN, tell Nmap not to do a port scan after host discovery, only print out the available host that responded to host discovery. I should make this larger because you totally can't see that, right? I want Nmap to talk to every IP address on my network, give it a ping, and respond to me. And then from that, I'll know what's responded to ping on my network. Okay, cool. Nmap-SN, what do I put in next? What's my network?
Could you do like an IP-C adder first to find it out?
Yeah, let's find out. Oops, that's not what I wanted to do. close you. IP-C, get that color. Okay. So I got my loopback address and I have two Ethernet ports, Ethernet adapters. Which one do you guys think is the one that's my local network?
The F0.
That's 0, right? It's 192.168. This is the IP address that I currently am. And so I'm going to assume here that the IP address of my Metasploit is 192.168.40. something. Not 199, but that's something. So cool. Copy. And map SN. Give it that. Let it, let it do its thing. Shouldn't take too long because we're just doing a ping sweep. Ran out of water, but that's okay. Wunderbar. All right. What do we got here? We got check 256 IP addresses and it says 5 hosts are up. Which one do you think is Metasploitable, or do we need more information? Would you like more information? How would you do it? And if me highlighting it makes that worse, I'm sorry.
You can check which one has port 80 open.
Hey, that's fair. That's fair. Which one of these can we knock out for sure is not it?
The first one, the 40.1.
Yep. This is going to be the gateway, so it's not that.
And also the last one.
Because this is us. So we have either 200, or 254. 254 and 2, I'll tell you right now, they're not. I'm pretty sure VMware makes these. I forget what they do exactly. But 200 is, and I'll show you. We'll confirm. I'll just do a regular nmap on it. What I expect to see is a whole bunch of ports open because it's running Metasploitable and it's, made to be exploitable for me to play with. Cool. It's got a whole bunch of ports open, ready for me to attack. Okay. The only one I want to show you right now is on 80 though. We're going to do the HTTP. Cool. So we got that port or IP. I'm just going to go right there. Here's my Metasploitable 2 box. Thank you guys for helping me find it. And I'm going to go ahead and log in. I already know the credentials to this machine. Okay, I'm already logged in. I'm just going to change the settings so that we can do it. All right, cool. So I'm taking you here to this brute force page. Metasploitable is just a box that has a whole bunch of already easy to, well, I wouldn't say easy to, but a bunch of vulnerable services running on it for you to practice. One of them here is so we could practice brute force. Okay. And so all this little app does here on this brute force page is you give it the username and the password and it'll let you log in. Now I already have the username and password. I'll tell you right now, the username is admin and the password is password. And if you do it right, you just get this. Welcome to the password protected area. Okay. If you type it wrong, you get that. Username or password is incorrect. There's nothing extra special to go through. It's just to practice breaking in to a login form like that. Okay. Any questions on just this part so far? Got drips. Okay, cool. So anytime I want to break into a login form like this, it's very important for you to understand how this is working. Right. So what you're doing when you hit login is we're sending some kind of HTTP request. And if I want to look very close at HTTP requests, I have two different ways. I have Burp and I have my browser. I'm going to look at this through the browser first, and I'll open it up in Burp as well. Okay, so again, I'm just going to open up here, have this network tab open and see what happens when I type in admin and the password 123. Login. Right, don't update. Okay. Apologize, I can't make this too much larger, but you'll see 4 GET requests got made. One of those GET requests is the one that actually had that information here. Apologize, I can't make this too much larger. Maybe Burp will make it bigger when I show you it in Burp. But the important things to see here is that We sent an HTTP GET request to log in. And where did we send the username and password? We sent them as query parameters. So if you look over here at the top, it says username equals admin and password equals 123 and login equals login. Cool. Also shows you here that we logged in with some cookies. We used some cookies for logging in. Okay. Things that are a little strange about this is that we're using a GET request to log in. That's usually not how we do it. We'll usually use like a put request and then put the query parameters inside the body instead of being inside, or put the login parameters inside the body instead of being in the query parameters. This is just one way you can do it. Okay, cool. Let me take a look at what this looks like in Burp instead of a browser now. So I'm gonna fire up Burp. I'm gonna tell my browser to use Burp as a proxy. Once I turn Burp on, you say close, I'm not updating. You say next, it's temporary. You say start Burp. Cool. Things that are important, you go to proxy, says intercept is on. Okay, now I have to tell Firefox to use the proxy. So if you go to about preferences, and you just search for proxy, there's the setting, manual, set it to localhost and port 8080, because that's where Burp is living. Cool, 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 cool. So now if I try and log in with admin and 123, hit log in, I want to update. Did I catch this? Oh, we didn't catch this. Maybe restart this. There it is. Okay. You go away. I accidentally opened it in a new tab. Let's do this again. Forward. Okay. Log in. Hey, how about you get caught? What if I do a hard refresh on this page? There it is. Okay, can I make this larger? I cannot, unfortunately. Anyway, here's the request, the GET request I used to log in. What I want to bring your attention to is that, yes, it's a GET request. Oops, you go away. Is that it's a GET request. It has the host right there. That's the IP address of the machine I'm going to. It has the resource I'm going to, /dvdeb, /vulnerability, /brute. It has the cookie right here. That's the cookie information. And then at the top here, there are the query parameters where it says $username equals admin, ampersand password equals 123, ampersand login equals login. So this is all of the information we're sending in order to log in. And so what I did here is I hit Control R so I could send this to repeater. It's the same thing. It's just that now I could keep hitting send and it repeats, it keeps repeating this request. So if I hit send with this information in that request, right, what I expect is at some part on the page, it says that you put in the username or password wrong. Where is that? Username and password or password is incorrect. Okay. So if I wanted to manually brute force this, the idea is, okay, well, 123 doesn't work. Let's try 1234. Hit send. Look at the response. Well, it says username or password is incorrect. Well, that didn't work. So let's try 12345 or 45, right? Send the request, look at the response. Oh, it says username or password is incorrect. Well, that didn't work. All right, let's try 123456. Right. I spelled 6 wrong, but it doesn't matter. The point I want to make to you is that what we're doing sounds like or looks like something that can be automated. We're not doing anything particularly intelligent other than find out how is this request being formatted, and then just changing the parameters and brute forcing them. And once you send the request, look at the response. Did we get logged in? No, try again. Okay, so let's try and automate this instead of with Burp. You can do this with burp. We're going to use the tool Hydra from the command line. Okay, cool. So now that we've done our research, we have an idea of how this thing works. We can start using Hydra. Okay, first thing you'll do is clear out and Hydra dash dash help. Hydra dash H. And you scroll to the top and you get a whole bunch of options. Right? It gives you some syntax right here. You do Hydra. You have dash L for login and dash uppercase L if you're going to use a login file. So like a whole bunch of logins, like credentials. You have dash P for if you're going to use a single password, dash uppercase P if you're going to use a whole password list. We have dash C for file. So that's if you're going to use a file that has the usernames and passwords already inside it, generally in the form of username : password. Here you have an output file. Dash T is tasks. I believe that's for how many threads you want to run, make it go faster. A whole bunch of other options here, but what I want to bring your attention to is this last part where you have service, server, port, and options. Okay, this part's important. And why we needed to do our research before you start using Hydra. So again, I'll take a look at the examples. Hydra dash L, so that means we're going to use the name user. Dash P for password list, that means we're going to use whatever's inside this password list passlist.txt. And here it says FTP. So apparently this is how you would use Hydra to try and break into this FTP server with the user, and any of these passwords inside the password list. Also, we just learned we can use Hydra to break into FTP. Doesn't have to be just web logins. In fact, we can use Hydra for all sorts of services. So I'm going to show you which those services are. If you look here in the Hydra help menu, there is a list here of supported services. So you have Adam 6500, not super familiar with, but you have Cisco services. Ones that we are definitely familiar with is IRC, right? Internet Relay Chat. You got SQL. So if you want to try and break into SQL databases, perhaps you would try this. You have SSH. So, right, let's say perhaps you have a user on SSH and maybe you think their password's guessable. Well, we can try Hydra to guess those passwords. Cool. So let's try using Hydra now to break into this web page. I already know the password, sure, but when you practice today, you're not. So we're going to use Hydra. Ooh, let me clear this. I remember, I won't forget this time. I'm going to do very verbose so that when we could watch it try everything. Watch it, we'll feel like cool hackers. So dash L for who we're going to use as the user. And notice it's a lowercase l because it's going to be the same one every single time. The user's admin. We're going to do uppercase P for the password list. And we're going to use RockYou. User share wordless RockYou. Cool. So that's that information. We now need to give it our target. So that's 192. Really our host 192.168. What are you? 4200. Okay. We got that there. Now we need to tell it what is the format or what service is it using to break in. In this particular case, we're using HTTP GET. HTTP GET form. How do I know this? Because I looked at it and it shows that this is an HTTP GET form. Right? We have a form here. Hit login and it's making a GET request with these parameters. So it's HTTP GET form. If it were a post, it would be HTTP post form. If it were SSH, it would be SSH, right? We just got to do some research and figure out what is the service that this is actually using. Cool. So the service is http-get-form. And again, if I didn't know, Hydra-h I would look at these services until I figured out which one it was. And here you have HTTP. You can use S if it's HTTPS. You have head, you have get, you have post, you have HTTP, you have get, you have post, and form. We're using this one, HTTP get form. Okay, cool. So let's do it. HTTP get form. And now the final part, and this is always the most challenging part to me, are the options that this HTTP get form needs. And this is generally where I'm going to look up, you know, like a guide for Hydra or something like this. Let me actually turn this proxy off. And I would Google something like Hydra HTTP get form. Google something like this. You can see I've already done this before and found a couple of useful tutorials. And this is because it requires some options for information. And what Hydra is going to require, what's the data that we're trying to send, right? We're putting in the username and password. So where does that need to go? We need to put in what is the location that we're actually going to for this login page. I should have switched the order. It's the order's reversed. And what do you need to look at in the response to know if you are logged in or not? So what do I mean by that? If we look into Burp Suite again, I need the resource we're going to. So that's /dvwa vulnerability /brute. I need the information we're going to be putting in there. That's this username admin, passwords 1, 2, 3, 4, 5, 6, and login equals login. I'm going to keep login equals login the same. And I need what do I see in the response that lets me know that I have to keep going. And the thing I see in the response is this, username and or password incorrect. If I don't see that in the response, we did it. Okay. The last thing that's important, in this particular case, we need to send it with these cookies. So I'll show you how to do this with cookie as well. Okay. So again, I copy and paste this. Yeah.
How'd you know to use the -get form? Why didn't you just use HTTP -get?
Because this right here is a form. You see how you have like this user input here and you hit a button? This is an HTTP get form. When you hit the button, it makes a get request with the data that you provided. If you look over here, and I apologize again, it's too small. When you actually hit the button, it makes a request here, and this is where that data that you put inside the form goes to. If it was a form that makes a post request, it would be HTTP post form. If there is no form at all, then it would just be HTTP -get or HTTP yeah, it has to have a form for post.
What would be a no form example?
I'm trying to think of one now. Honestly, I don't know. I always see it as either HTTP get form or HTTP post or put forms. So that's a good question. I can look into, but I just never see that, honestly. That's a good question. I haven't been asked that before. I'll look it up. Okay. So for this part, I always copy and paste because I swear I screw it up every single time. So I copy this, the resource we want to go to, copy. That's the first thing I put in there, paste, and I put a colon. And then the next thing I put in there is the information we're trying to replace, which is this stuff right here. I'm going to copy that. I'm going to paste it, except here, where it says username equals admin, I'm going to replace that with caret user caret. And what this does is it'll replace user caret with wherever it sees here, this L variable. In this case, it doesn't matter. I could have left it as admin because we're never changing it. But if I were trying to do like perhaps a password spraying attack, or I'm trying multiple usernames, right, from a file, this is where I would, this is where we're replacing this as a variable. Where does this come from? Why is it caret user caret? I don't know. Hydra. This is the format that it takes it. For password, instead of 1, 2, 3, 4, 5, 6, I want to replace it with caret pass caret. And this will, every time we run this, or every iteration, right? Instead of having caret pass caret, it'll have whatever was in one of the lines of rocku.txt. Okay, cool. So that part looks good. This login equals login, I'm just keeping the same because it doesn't look like that changes. The last thing I told you, or second to last, I should say, is what do we need to look at in the response to know that we keep going? And that's this. Username and or password incorrect. It'll be different every single time for you, right? You know, it's just something you're looking at on the page, and this is why you have to do your research before you throw it in the tool. So I'm going to copy that. I'm going to paste that. Okay. There's a thing I have to add for this specific instance. I'm not going to add it because I want you to see this not working first. I want you to see what happens when your Hydra is not set up properly. Okay. We're almost there, so I'm just going to hit run. All right. So I made it very verbose. I'm just going to scroll to the top here. So what I ran was Hydra-VV, very verbose, with the username admin, the password from RockU. This is the target, 192.168.40.200. This is the service, HTTP GET form. This is the options. Go to this resource. This is the data that we're going to replace. This is what you look for if it's not correct. Okay. What happens if you do Hydra wrong? Well, if you're very verbose, that you don't have to do very verbose, but what you will see is it runs each of these attempts, right? Try to log in with admin and pass 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, 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 right? It tries this. And then you'll notice here at the bottom, we got these that are saying that they work in green. How do I know that I did this wrong, firstly?
Too many positive results.
Yeah, right. Obviously, this is I must have done something wrong because it's telling me all of these are valid passwords. So when you see this, no, you must have done something wrong. I'm telling you, I've done this all the time. I always screw this up. So that at this point, when you see this happen, you want to look and very carefully look at the requests that you were sending, how you were doing this, and see what you were doing wrong. And the difference I see here is I am not sending the cookie. So you know, you have to look up, how do I send the cookie then? And I've done this before. I've done the work for you. You could just kind of Google like Hydra HTTP GET form with cookie option, something like that. Right. And you'll find someone that has done this problem before and someone else who is like, look at this, look at this. Almost the same thing they've tried doing. Doesn't work. Well, looks like you can use this option to add the cookie. So I'm going to do that. Right. Looks like you just says H equals cookie and then paste the cookie right there. Cool. So I'm just going to do that. Colon H equals cookie colon. And then I'm going to go right to burp. Grab this. Right. That's the cookie. Copy it, paste it, and cross our fingers and hope it works. See, now this is this is what you want. You want it to run, and then you want it to stop after one hit. So now it's telling me the login is admin, and the password is password. We can go and try it and confirm. So I just kind of wanted to show you using this tool, and I wanted to show you doing some troubleshooting, debugging, because I promise you this happens all the time when you're trying to use Hydra. You're going to get a lot of false positives. And if you got false positives, that means you probably did something wrong. The most common thing, the most common troubleshooting thing I will look for when I screw it up is these options, right? That last part, think about it. That's where it's like the most complicated thing that we're doing. Where is it? Where is it? This part. So I'll like kind of Google around, how do you actually set it? I make sure that this string that I'm looking for on the page is actually there, right? Run a couple sanity checks. And again, have burp open to copy and paste all of that information inside there. Cool. There are other tools that do the same thing. Hydra is just one of them. But I really want you to take away from this, like, how do we how do we brute force these attacks? Well, try and log in with a valid username and a potential password. Take a look at what the response is. If it's not in, try something else, right? It's a very stupid tool. So it's up to you to kind of, set it properly. Other tools like Hydra, if you want to try using something else, because they are available, there's Medusa. Medusa's not on this. All right, well, you can install Medusa. I've used it before. It works very similarly. I think one advantage of Medusa is you could set the threads on this. Another one that I've used before is Patater. It's not installed by default. You have to look for it. Patater. Oh, that's not helpful. Password attack. Patator. You can try this tool if you're interested in it. It's useful. I think in the README of the guy that made it, he was like too frustrated using Hydra and he wanted something that was a little easier to use. Your mileage may vary. The point I want to show you is that this is how the tool works. It's up to you to choose one of your tools and just get familiar with it and friendly with it. Cool. Questions, options, concerns.
I have a question, Matt.
Yeah.
Is there any way, so the failed message, I think we put invalid user ID. Is there any way to pass 2 messages or it's only 1?
I only know of 1. I don't know of an option to set 2. What is the situation that you're thinking of where there would be 2 different confirmations that you are not there?
Instead of passing a password, let's say we just leave it blank. And maybe that will give you a different error.
Oh, so you're trying to see if there's a user? Is that the idea? With that username? And even then, what's the point? Like, I guess what's the point there? Like, sure, let's see if we get a different error, but well, we don't get one in this app, but what is that going to help us do, I guess? Try to think.
Because if you put in just a blank password, maybe the error will be it will be a different error. So Hydra will think, hey, it's not saying invalid or incorrect password, so that means it's the right password.
I see. Okay, so two things there. The only way Hydra would try to use a blank empty password is if one of the lines on the file you gave it was empty, right? Like you have to specifically tell it to try to use blank password. I don't know. This seems like such an edge case. Like I don't think it's going to be an issue. I think it's like such an edge case, right? There's only one condition, right, where it's just no null password and you get something different. So no, as far as I know, I only know of one like flag thing that it's looking for to know if the authentication attempt was failed. I don't know how you could make it or something. That may be possible in one of the other tools, but I don't think so.
In general, is the username and or password incorrect? Is it usually, can we see that on the page a lot of times?
Yeah. Try and log into most of your pages.
Right.
Most
that's
sites.
what I was thinking. Yeah. Most sites have so usually is that the string we need?
Depends on the site, right? You got to look at the site. Some of them will say something slightly different. Some of them won't, right? But you're going to look for some indication that the authentication was failed. And that is what you need to tell Hydra, because that's what Hydra is going to look for to know if it found a match or not. Because remember, Hydra's a stupid tool. All of them are.
Right, but what I mean is usually the string that we see on the screen going to be the same thing that we would find if we dig around into Burp.
Oh yeah, you'll definitely find it. You'll definitely find it here in the response. Right. So I encourage you first to manually on the web page try things. Right. So you encounter a login form, right? Where we're on PWK, you find a page that has a login form. First things you want to do are like, what is this application? Try some default credentials. Okay, default credentials, if they get you in, awesome, right? You don't even have to do that much work. But now you need to find either a user account and try a list of passwords to attack, or you have to try, brute forcing both the username and the password. That takes, at least twice as long. Does that make sense? Did I answer your question or no?
Yeah, that's good.
Okay. Sure. That wasn't a super confident. Yeah.
Well, what you were saying made sense, but I was asking something slightly different, but I can figure it out.
Can you ask it again in a different way? Maybe I can help.
What I'm trying to say is like, is it usually such that in the GET request, when we look at the brass tacks of the GET request, are we going to see the same thing that shows up on the screen when we fail to log in?
So in the GET request itself, no, in the response you will.
Yeah, in the response. I'm sorry. Like when you look in
Yes.
Burp Suite in the response and you see that thing, it's seen in this case, it seems to be the same thing that showed up on the screen.
Yes, because this response, all this stuff here, right? Like, look, here's the header of the response, but all of this is the raw HTML, right? Like this is, if I go view page source, right? Well, where's the rest of it? Oh, yeah, password, username and/or password is incorrect. That is everything that's here. It's just not rendered in the browser. So yes, anything you see in this response, you will see it in the response here in Burp.
Right. So we can almost get it from just the page we're looking at, as opposed to going into Burp to get it.
Oh yeah. The advantages of Burp is you could see this cookie thing. I mean, you could do it in your browser too. You could totally do it in your browser too. I'm just showing you a different tool. But yes, you can look at it right there. 100%. All right.
Just out of curiosity, what's your opinion on the tool Offcrack?
Offcrack. I'm not super familiar with it. Offcrack.
Okay, never mind.
I'll look into it. Oh, Offcrack like this. Password
Yeah.
cracker based on Windows. Based on rainbow tables. So I'm gonna guess you need a free Windows password cracker based on rainbow tables. Very implicit. Cool. I mean, seems cool. I could look into this, but I'm gonna guess you need a lot of hard drive space to actually keep this rainbow table. Rainbow tables are really cool. If you are a hardware person, you just want to have some. They're cool. I just don't. All right. What are we going to work on today? Today, we've got some activities with password attacks, which I'll show you right here. So here's the workshop of the day. Password attacks. There are some offline password attacks. You'll work on these first with your partner. Then you'll have online password attacks. We got you a little web app right here, kind of similar to what I did. You're going to be hacking Corey, aka our karate fish. He gave us permission to do this. This is totally fine, right? So you're going to kind of be doing an online password attack and an offline password attack. Figure we can do this in probably 90 minutes. So we can come back together. You take, give me 5 minutes so I can set up breakout rooms. And then we'll be working on this. After this, we have a box for the day. I believe the box we're going to be working on today is core, but that'll be later, probably in the afternoon. Maybe a little before afternoon.